All right, so looking at these, we're going to start talking about graphing these compound inequalities. So the last lesson that we did, we talked about numbers and what makes true for and or. Now we're going to look at what it looks like on a graph. So for number one, letter A, we're going to graph these separately. I'm always going to graph the left one with red and the right one with blue so we can kind of see where what's going on. So the first one is going to be an open circle on 1 because it's not or equal to, and it's everything that is less than 1. And for the second one, it's a closed circle on 4, and it's everything that's more than 4. You'll see that those go in the opposite direction, and that's pretty typical about or compound inequalities. The next one, x is more than 7, so that's an open circle on 7. And the right one, x is less than -2, so again, it's an open circle and everything less than. Letter C and letter D are both and inequalities. It also asks you to write those in a single inequality, and we'll go over that in just a bit. But for the first one, I'm just going to put the circles so that I remember if it's open or close. So I have -3, that's an open circle, and I have +5, that's also an open circle. You will see that I need everything more than -3 but less than 5, so that's everything between the two. You could have graphed them separately like you did up above, but your actual answer cannot have arrows in it for and equations. Now looking at the single inequality, we're always going to have x in the middle because we're showing that x is in between two values. So x is more than a number, but less than another number. And this is where you make sure that your inequalities are both facing, they're both eating the right direction, I guess. And then you have your smaller number on the left and your larger number on the right to show that x is going to be between a smaller number and a larger number. So the next one, we're going to have a closed circle on 9 and a closed circle on 0, and x is less than 9 but more than 0, so it's everything between. So it's everything between 0 and 9. So we're going to graph each of the following, but first we're going to take that single inequality and make them into two inequalities because sometimes it's easier to read it that way. So I know that x and -4, something's going on with those, and x and 6, something is going on with those. What you need to pay attention to is the direction. So in the first one, that inequality is eating the x, don't forget about the or equal to, and in that second inequality, we don't change the direction. It's exactly as it was written. So x is more than or equal to -4, so it's a closed circle. X is less than 6, so it's an open circle, and you graph everything between the two. Next one, x and -5, and x and 9. Remember that this one does not change direction, but the other one, that the inequality stays the way it was originally written. So we have -5, it's or equal to, so it's a closed circle. And we have 9, it's or equal to, so it's a closed circle. Remember, x is in between the two, so it's everything in between the two. A and B, we're just going to write inequalities for these. You will notice that A, they don't ever cross, so that means it's going to be an or. So x is less than, it's smaller than, notice how it's an open circle, so it's not or equal to, and -1 is the number that this is on. The second one, x is more than or equal to, notice that that is a closed circle, 5. The second one is an and, so we're going to write that as a single inequality. Notice how both are open circles, so we're going to keep those as just less than and more than, not or equal to. The smaller numbers, so I have -6, 7, 8, so -8, and the larger number is 2. Now we're going to put together our skills as solving inequalities from previous lessons with compound inequalities. So first we're going to look at this compound inequality. It's an and we're determining whether or not these different values for x are answers for the equations. So we're plugging in the numbers given for x to determine if they are true. All right, you'll see that once all of them are solved, and since it's an and, both of them have to be true. So x equals 5 works, x equals -3 does not because of this false, and x equals 10 does not work because of this false. Now we're going to solve the compound inequality and graph the solution. 6x plus 1 is more than or equal to 4. So we're going to subtract 1 first. So 6x is more than or equal to 3. Then we divide by 6, so x is more than or equal to 1/2. So that would be a solid circle at positive 1/2. The next equation was -2x plus 8 is more than -12, and we subtract 8 from each side. So -2x is more than -20. Divide by -2. Because we divided by a negative, that switches the sign. So instead of x being more than, x is now less than positive 10. That is an open circle. And remember, since it's an and equation, then it's everything in between. These next ones are just like the one we did before, so go ahead and pause now and work them out yourself. Since this problem was an or, then only one of them has to be true in order for it to work. X equals -6 does work because one of them is true. X equals 0 does work because both of them are true. And x equals 8 does work because the second one is true. So we're going to solve 1/2 times x plus 4 is less than 5. We're going to first multiply each side by 2. And by doing that, we now have x plus 4 is less than 10. Subtract 4 from each side, and x is less than 6. So it's going to be an open circle on 6, and x is everything less than. The next equation, -2 times x minus 4 is less than or equal to 14. We're going to divide each side by -2. Remember, when you divide by a negative, it switches the inequality. Add 4, and x is more than or equal to -3. So we go to -3, more than or equal to, and it's going to go in that direction.